Alright, if you're watching this video, you were either absent on Friday, March 31st, or you just need a little refresher and you're getting ready for the test. So on the warm-up today, we decided that we're going to practice expanding binomials. The first one says x plus 1 squared, which means we're going to go multiply x plus 1 times x plus 1. So we're going to FOIL. When we FOIL, we get x squared plus 2x plus 1. On example 2, if I were to expand it, I have x plus 1 times x plus 1 times x plus 1. Well, I've already done this part. We did that on the example above, so I can just write that down. Then I have to take that answer that I just got and multiply it by x plus 1. So not a big deal. X squared times x, x to the third. X squared times 1, x squared. Now go to my next term. 2x times x, 2x squared, 2x times 1, 2x. Last term, 1 times x is 1x, 1 times 1 is 1. And then I'm going to combine like terms. And we're done. So the whole reason we did this in our warm-up today is because we're going to actually talk about expanding binomials to bigger powers. It really wasn't that big a deal to do it squared or to do it to the third. But if I were to change this third to the fourth or the fifth or the sixth, it would require a lot more work and a lot more time. So what we discussed in class today was this theorem called the Binomial Theorem, and it's used for expanding binomials to the n power. So it's not a formula, it's a pattern. And I tried to stress this a lot in class today. Whenever we're trying to use the binomial theorem, we need to remember that it's a pattern that we're changing. And in the pattern, this first part of the pattern reads n choose 0. The second part will be n choose 1. And then we'll have n choose 2, n choose 3, n choose 4, n choose 5, until at the very, very end, whatever number we have on top is the same as the number we have on bottom. That'll be the first part of your pattern the whole way through. The second part of your pattern will require that you take your first term and you raise it to the n power. And then every time you move to the right, you're going to take one number away. So this would be x to the n minus 1, n minus 1, n minus 1. It just keeps getting smaller and smaller and smaller and smaller. The third part of the pattern requires that you take the second term. And you're going to take your second term, whatever it happens to be, and you're going to start by raising it to the 0 power. And then you're going to raise it to the first, the second, the third, the fourth, the fifth, until you get to the n power. The best way to understand this is actually go and do an example with me, and then it'll start to make more sense. Before we can go through the pattern, we have to understand what this part of the pattern means. N choose R. N choose R is a way of doing combinations, and the formula is actually n factorial divided by r factorial times n minus r factorial. You don't need to worry so much about this part. We just need to make sure you can type this in your calculator. When you get to your stat class, you'll talk more about that. So to type it in the calculator, we're going to do a little practicing real quick. So if we have a problem, and we will in a little bit, where we have 3 choose 1, this is how you type it in. First thing you do is you type in the n, which happens to be your top number, so 3. Then you're going to go to your math button. You're going to arrow over to the right where you see PRB. And you're going to arrow down to NCR. You're going to hit enter. So now your calculator reads 3 choose, and I want you to choose the number 1. 3 choose 1 is 3. Okay, I'm going to go practice it again. So I always type in the first number, 4. Go over to math, arrow over to probability, down to n choose R, and it's n choose R. My R is 2. Second one is equal to 6. All right, next one, 8. I'm going to go over to math, probability, n choose R, and it's 8 choose 7. So the last one equals 8. now that we know how to do these in choose R's in my calculator, I can go practice using my pattern. So the first one we're going to learn how to do is we're going to learn how to expand 2x plus 3 raised to the 5th power. When you're doing this, every time you do your pattern will always start with whatever n is, choose 0. N is going to be whatever this power is. So we're going to start off with 5, choose 0. The next one would be 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, 5, choose 5. You're done when you get to 5, choose whatever the power is. So that's the first thing that's going to be in front of every term. The second thing that's going to be in front of every term is you're going to take your first number here, whatever it happens to be, and you're going to raise it to the n. So I'm going to have 2x to the 5th. And the last thing you have to do, you have to do 3 things. The last thing you have to do for each one of these terms is you're going to use your last number and you're going to raise it to the 0. So here's what's going to happen. The one in purple, this number at the bottom is going to go 1, 2, 3, 4, 5 every time I move to the right. The one in green, this exponent is going to decrease. It's going to go 4, 3, 2, 1, 0. The red one, the exponent is going to increase. It's going to go 1, 2, 3, 4, 5. So the two on the outside are going to go up by 1. The exponent in the middle is going to go down by 1. And we're going to do that until this number right here says 5, choose 5. So they're the same. All right, so here we go. I'm going to put a plus. And I'm just going to keep the pattern going. 5, choose 1, 2x to the 4th, 3 to the 1st. Both of these went up 1. This one went down 1. And I'm going to go again. 5, choose 2, 2x. This time I'm going to go to the 3rd, 3 to the 2nd. It went up 1. And this happens to me a lot. I already ran out of room, so I'm just going to come down here and continue. So I had 5, choose 2, 5, choose 3, 2x squared. Remember, the green ones are going down. 5, 4, 3, 2. The red ones are going up. 0, 1, 2, 3. And I have to keep going again until I get 5, choose 5, and I'm not there yet. I'm at 5, choose 4, so we're almost there. 2x to the 1st, and then 3 to the 4th. Okay, I got one more to do. 5, choose 5, 2x to the 0, and 3 to the 5th. All right, so that's just your initial step. You just write it all out. From here, it's about going to your calculator. So I'm going to go to my calculator, and I'm going to type in this first part right here. 5, choose 0. So my first number is 1. So 1. 2x to the 5th, I know 2 to the 5th is 32, and x to the 5th. And 3 to the 0 is 1. And I'm going to take all 3 of these numbers, and I'm going to add them up. Multiply. 1 times 32 x to the 5th times 1 is going to be 32x to the 5th. So that's my first term in this whole thing. Now I'm going to go to the next one. I'm going to do 5, choose 1. So 5, choose 1. 5, choose 1 is 5. So this right here is a 5. 2 to the 4th is 16x to the 4th. And 3 to the 1st is 3. I'm going to take all 3 of these numbers up here, and I'm going to multiply them together. So 5 times 16 times 3. 240 x to the 4th. We'll do it again. I'm going to do 5, choose 2. So 5, choose 2 is 10. 2 to the 3rd is 8x to the 3rd. And 3 squared is 9. I'm going to go multiply all 3 of those numbers together. 10 times 8 times 9. You get 720, and we have our x to the 3rd. We're going to keep this going. So we have 5 choose 3. 5 choose 3 is 10. 2x squared is 4x squared. 3 to the third is 27. So we do 10 times 4 times 27. We get 1080x squared. 5 choose 4, we get 5. 2x to the first is 2x. 3 to the fourth is 81. So we do 5 times 2 times 81. We get 810x. 5 choose 5 is 1. 2x to the 0 is also 1. 3 to the fifth is 243. So 243 times 1 is 243. Again, it's just a pattern. The hardest thing about this is that you have to go type all these numbers in. If you don't like using this, then the other option is to use what we call Pascal's triangle. In order to use Pascal's triangle, you have to know how to create Pascal's triangle. So the first thing you have to know about Pascal's triangle is it starts with a 1, and all of the edges in your triangle, the whole outside, will be 1s. The inside of your triangle will be the middles added up. So there's no middle to add. I just said all the outsides are 1. I go to my next row. Now I have a middle, because what's 1 plus 1? 1 plus 1 is 2, and the outsides have to be a 1. Now I have two middles. 1 plus 2 is 3, 2 plus 1 is 3, and the outsides have to be a 1. I've got 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and the outsides have to be a 1. I'm going to go at least 2 more times. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and the outsides are 1. We do one more row. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and the outsides are 1. All right, so let's talk about how this is going to help us. This first row up here would be something to the 0 power. The second row would be first power, second power, third power, fourth power, fifth power, and sixth power. So whatever row you're on, that's going to tell you what power. So the first row is a 0 power. The second row is the first power. Third row is the second power, and so on and so on and so on. So let's see how this compares to what we just did. The one we just did was a fifth power. And if you look at the fifth power chooses, this will be my fifth row right here. When I did 5 choose 0, I got 1. When I did 5 choose 1, I got 5. When I did 5 choose 2, I got 10. When I did 5 choose 3, I got 10. When I did 5 choose 4, I got 5. When I did 5 choose 5, I also got 1. So these numbers in the row are these things in the purple. It's just another way of getting those numbers without using the calculator. So what I'm going to do now is I'm going to do one where I use the Pascal's triangle instead of using the n choose r. Because it says to the 6th power, I have to go count down 7 rows. 0, 1, 2, 3, 4, 5, 6. This will be the 7th row. 1, 2, 3, 4, 5, 6, 7. Alright, so this row is going to be all those n choose r's, but they're just done for me. I don't have to type them in. So the first number you're going to write down is the first number in the pattern, 1. Then I'm going to have 2x to the 6th power, negative 1 to the 0. Remember, this pattern is not going to change. This number in the middle is going to go 6, 5, 4, 3, 2, 1, 0. And this number at the end is going to go 0, 1, 2, 3, 4, 5, 6. Okay, the next term. 6 comes next. And then we're going to have 2x to the 5th, negative 1 to the 1st. Next term, 15. 2x, remember these are going down to the 4th, negative 1 to the 2nd. Okay, we're going to do it again. We've got 20, And we've got 2x to the third, negative 1 to the third. Come down here because I ran out of room. After 20 comes 15. We've got 2x to the, that said 3, so I need 2. And I need negative 1 to the fourth. You're done when you're done with your row. It's 15. I bring down my 6. I've got 2x to the first, negative 1 to the fifth. And I've got one more left. Got 1 out front, 2x to the 0, negative 1 to the 6. And now from here, it's a lot like we did earlier, except I don't have to do any in chooses. I just have to type in the numbers and multiply. So I've got 1 times 2 to the 6. So 2 raised to the 6 is 64. X to the 6, and negative 1 to the 0 is 1. So 1 times 64 times 1. 64x to the 6. Okay, my second term. I've got 2 to the 5th, which is 32. X to the 5th. Negative 1 to the first power is negative 1. And then I've got my 6. So we're going to type in 6 times 32 times negative 1. So we get a negative. So instead of being plus like we've been doing, it's going to be minus 192x to the 5th. Okay, let me go do one more, and then I'm going to assume you can keep the pattern going. So we have 2 to the 4th, and 2 to the 4th would be 16. I got my 15 out here. And then I have negative 1 squared, which would be positive 1. So we have 15 times 16 times 1. So plus, because it came out positive, 240 x to the 4th. And you just keep this going. You just need to decide, do you want to use the in choose R method or the Pascal's triangle? Whatever method works for you is the one you need to do. The last little thing I showed y'all today was how to use the formula to find a particular term. So when you're working the test, they might have a problem where they say they want the 50th term. Well, I would never want to expand something out 50 terms if I did not have to. So you don't have to if you know how to use this formula here. This formula says that you're going to do n choose r. Remember, n is your power. And r is going to be 1 less than the term number they ask you for. So if they ask you for the 50th term, your r would be 49. If they ask you for the 100th term, then your r would be 99. Okay? So n is your power. R is 1 minus whatever they ask you for. A is whatever your first number is. B is your second number. All right, so let's go do one. So this one says x plus 2 to the 9th power. And they want me to find the 6th term using this formula. So A is the first number, so it's x. B is the second number, so it's 2. N is your power, so it's 9. And R is 1 minus what they're asking for. So they want the 6th term, so 6 take away 1 is 5. And now I'm just going to go plug into this formula. It says to put n choose r times a to the n minus r power. Well, 9 minus 5 is 4. N minus r is 4. Times my second number, which is 2, to the r, which is 5. So I'm going to go type this in. Remember, n choose 5. I mean, 9 choose 5. So type in 9. And you go over to math. Down to n choose r. And you type in 5. So 126. X to the 4th is x to the 4th. 2 to the 5th is 32. And then you multiply. So 126 times 32 equals 4,032 x to the 4th. The assignment I gave today was to do 11.5. It was on the back of last night's. And I got rid of number 23. Remember, all your homework is due Monday and your test is this Wednesday. If you are absent the day that homework is due, you give it to me the very next time I see you. If you're absent on Wednesday, the day of the test, you'll take it the very next time I see you. Good luck!